Hey everyone! Today in class we are going to learn how to add and subtract fractions that have different denominators. So, prior to this, our conversation revolved around the process of adding or subtracting fractions. Let's write down the calculation of 1, 2 plus, for example, 1, 2. When working with fractions that have the same denominators, we leave the denominator unchanged and simply add the numerators together. Ultimately, it transpires to be 2 halves or it will be 1. Everything is going really well in this place. However, if we require a solution for a different issue, then let's examine it together. So, I would like to add 1/3 to 1/2. So could you kindly explain what is occurring in this case? I am curious to understand the process behind it. Let's imagine. So, if I grab my small square and sketch a fraction representing 1/2 by dividing it equally into 2 parts, I can visually depict the concept. So this here is this part. It is 1 part out of the total of 2 parts in this context. And it is necessary for me to add an additional 1/3 to the existing amount that I have. So like in this manner, approximately 1/3. So what do I ultimately end up receiving as my final outcome or result in the end? Well, let's think together, shall we? How can I combine them? I will not be able to merge them because I have denominators that are different. I am unable to perform the task. Could you add them up to what? I wonder why I am unable to do it. Therefore, I am required to add 1 part out of the 3 parts in order to achieve the desired outcome of making it half. Well, I ended up with a collection of completely mismatched parts. So, like, what is the issue I am facing, you know? I need to solve this problem and come to this occasion. So I need to make it so that the denominators become the same. How can I achieve this? Let's brainstorm. What actions do we need to take? Take a thorough look. If I examine this area and see 2 separate parts, and in this area I see 3 separate parts, I need to find the total number of parts that I can divide both this little square and this little square into at the exact same time, without any leftover parts or fractions. I am in need of determining the total number of parts into which I can divide both this square and this little square at the exact same time, without any time gap or delay in the division process. What can I do? And that's where the least common multiple comes in handy for us. So the least common multiple allows us to find the number of parts we can divide both the first and the second into. So the least common multiple of numbers 2 and 3. The LCM of numbers 2 and 3 is 6, which is the least common multiple. What can I do? I can divide this square into 6 equal parts. Let's label them 1, 2, 3, 4, 5, and 6. So what's the next step? And this square I can also divide into 6 equal parts. If we label them as 1, 2, 3, 4, 5, and 6, what do I get as a result? I obtain some other fractions. What fractions do I get here? Let's see. In this section I have 3/6, and in this section I have 2/6. Therefore, the total is 3/6 plus 2/6, and I have successfully achieved the same denominator. By dividing the square into 6 equal parts and labeling them accordingly, I can clearly observe the fractions and their sums. This method allows for a better understanding of fractions and their relationships within the given shape. It enhances comprehension and facilitates comparison between different fractions. So I arrived at this particular situation. So the denominator remains unchanged, which is 6. I add 3 and 2 together, and the outcome is 5/6. Okay, I have solved this problem and determined the value of the sum. So I combined these 2 fractions together. However, what was the problem that I encountered? Take another look. So here's the thing. I had an issue where I needed to have 2 parts here, but there were 3 parts present here. I found a number that I divided by so that it would be the same for me. And then I realized that I possessed it, that this portion, it is divided into 3 equal parts. So my 1/2 was converted into 3/6. Well, how did that conversion take place? What caused my 1/2 to change into 3/6? And my 1/3 transformed into 2/6, undergoing a remarkable change that left me astounded and filled with awe. How did this guys turn out? Oh, you know perfectly well. So if I multiply 1 by 3 and 2 by 3, I will get 3 and 6 as the respective results. In this particular case, if I were to multiply 1 by 2 and multiply 3 by 2, the outcome would be 2/6. However, the issue is that the problem is exactly what it is. Therefore, we must determine the number of equal parts are required to divide it into. And that is the precise moment when the least common multiple comes in handy for us. Essentially, the least common multiple will be referred to as the least common denominator by us. So, we'll use this abbreviation. But the LCD is the same as the LCM, which stands for least common multiple. So what do we end up with? Let's return to our example, 1/2 added to 1/3. So what action did I take? I found the smallest common denominator for the given numbers, which were 2 and 3. It is going to be 6. So I wrote it down as 6. What did I do after that? So you can see, like, from one to the other, I had 1/2 and I obtained 3/6. Hence, the result of dividing 6 by 2 will be 3, as 6 divided by 2 equals 3. Following that, divide 6 by 3 and you will obtain 2. Consequently, I ultimately end up with the product of 1 multiplied by 3 plus 1 multiplied by 2, and as a result we get 3 plus 2 divided by 6, that will be 5/6. We got 5/6, and we also got 5/6 using arithmetic operations. That is what I'm talking about. 5/6 I got here by dividing into equal parts. That's the whole point of adding or subtracting fractions with different denominators. But that's when I came to this conclusion. By dividing this square directly and finding out that my fraction 1/2 turned into 3/6 and my fraction 1/3 turned into 2/6. However, it is not always convenient to perform this operation by dividing or depicting these fractions on the picture. So there is a specific algorithm. Okay, the initial step we take. We are positioned at the top. We determine the least common multiple or least common denominator for a pair of numbers, that is, for two given denominators. We discovered it. Proceeding to the next step, we are jotting down additional factors that we deem important for consideration. They come by dividing the common denominator, by dividing each of our individual denominators. One more time. How did I get 3? That's 6 divided by 2. This is what took place. I have obtained a numerical value of 3. Subsequently, I performed the operation of dividing 6 by 3, which resulted in an outcome of 2. Then I multiplied 1 by 3. In Act 3, 1 multiplied by 3 plus 1 multiplied by 2 to get the final result. And as a result, I got our response. So here's how you add or subtract fractions with different denominators. We'll collaborate on this algorithm, solving specific examples together so you can learn to add or subtract fractions with different denominators. That's all for today. Goodbye and see you next time.